Hi, in this video we are going to be looking at the centers of convergence of power series and to be able to find the interval of convergence of a power series. So very specifically, I'm looking at the power series to sum from n equals 0 to infinity, 1/3 to the n minus 1 to the n x plus 2 to the n. And I first want to find the center of convergence. And so we note that the series evaluates to 0 when x is equal to -2. And so, or sorry, all the powers of x evaluate to 0. The whole series doesn't because there's still a n to the 0th term. But still, x equals -2 is the center of convergence. The next thing we want to look at is the radius of convergence. So the radius of convergence is r equals 1 over the limit as n goes to infinity of the ratio of coefficients in a adaptation of the ratio test. So in this particular case, that is 1 over the limit as n goes to infinity of, and again, we have a alternating action going on here, but since we're taking the absolute values, we should just drop that. And so what we have is 1/3 to the n plus 1 over 1/3 to the n. This gives us 1 over the limit from n to infinity of simply 1/3, which is 1 over 1/3, which is 3. So the radius of convergence is 3, and the center is at -2. So let's sort of draw that out. Uh, we have our center of convergence at -2, and then we have a radius of 3. So that means up by 3 gives us 1, and from -2 below by 3 gives us -5. And now our question is, does the series converge at those values? So we can ask that very directly. When x is 1, right, the series n goes from 0 to infinity, 1/3 to the n minus 1 to the n, x plus 2 to the n. When x is 1, that's equal to the sum from n equals 0 to infinity 1/3 to the n minus 1 to the n, 3 to the n. And then we notice that n copies of 3 with 1/3, that's just going to be 1, right? So that those products are just 1. We're just left with the alternating series minus 1 to the n, which does not converge. On the other hand, when x is minus 5, the original series, that's going to be equal to the series 1/3 to the n minus 1 to the n minus 3 to the n. But we notice that this product here, minus 1 to the n with minus 3 to the n, that would just give us positive 3 to the n, and just like before, that is going to give us the series 1 over n when we take this product, which is just 1. And adding 1 to itself repeatedly definitely doesn't converge, which does not converge. So all we're left with then is everything leading up to from minus 2 to 1, but not including 1. And minus 2 all the way down to minus 5, but not including minus 5. So that tells us exactly what the radius of convergence is, or the interval of convergence. Is the open interval minus 5 to 1, not including minus 5 and not including 1, but everything in between. All right, thank you very much. I will see you in the next video.